Alright, this is Zach. I'm going to be talking about a little bit of the physics behind electro. So first thing first is we're going to talk about electro practically just being a giant battery.
Electro is like a battery because a battery stores chemical energy and then converts it into electrical energy. And we can see Electro do this when he absorbs the electricity from different sources, like in the final scene when he's grabbing it from the power plant, or in the opening scene he's grabbing it from the power lines and he's grabbing it from the city in Times Square. This is Sam, by the way. I also did the last one. But Electro is also a battery because when a battery can also release energy, and Electro just discharges his energy through lightning bolts, as you can see here when he uses a lightning bolt to attack Spider-Man. Thirdly, we have the flow of electrons. In a battery, the electrons flow from a terminal to another one, and Electro does this to basically, I don't want to say teleport, but like move through electricity, if that makes sense. Like he can go through the air through electricity. Now, Electro could also be compared to a capacitor. And first reason is because he gets energy, he stores energy rapidly. Capacitors really charge up quickly because they get all the electrical energy. And Electro absorbs the energy from from power grids instantly. Now, Electro is also like a capacitor because capacitors can release energy in really fast, sudden bursts, which we can see Electro do here when he is facing Spider-Man in Times Square and basically flips the car in Spider-Man with the electricity. And the final reason why Electro could be like a capacitor is because capacitors can explode if they exceed the maximum voltage which they can withstand. And Electro can be defeated by overloading him, which we'll get into next. Now, in The Amazing Spider-Man 2, released in 2014, Andrew Garfield's Spider-Man defeats Electro by overloading him and resetting the city's power grid. Now, we all know the story of Spider-Man, bitten by a radioactive spider, blah blah blah. Now, what if, instead of getting bitten by a radioactive spider made by Oscorp, he was bitten by a radioactive lemon? And instead of Spider-Man, he became Lemon Man. How many lemons would it take for him to defeat Electro and save New York from mass destruction? Okay, so we know that Electro overloads at around 13,900 volts. It kind of fluctuates in the scene, but we know that 13,900 is around where he overloads. And according to Google, a lemon is around 0.9 volts. So we simply do 13,900 volts divided by 0.9 volts, and that gives us 15,444 lemons, which Lemon Man would need to use. Now, how much power would that be? Now, we could use the equation P power equals voltage times I, the current, and we'll pretend that Lemon Man uses lemons in series. So the current would stay the same throughout. And according to Google, again, a lemon current holds about 0.0001 amps. So we will multiply 13,900 volts, can't forget the units, times 0.0001 amps, and that would be 13.9 watts of power, which isn't really a lot when you think about it, but Lemon Man's really just that powerful that he can defeat Electro. And that was our physics capstone. I say our, Zach obviously contributed so much to this. Those 16 seconds were amazing. And thank you for a great year, Mr. Lesher. Hope you have a great summer. And yeah, Ultimate Frisbee, look out for it. Maybe we'll see Lemon Man on that field, who knows. But yeah, that's been our capstone, and have a great summer, Mr. Lesher.